In this clip, we'll take a look at some examples of feature transformers. Feature transformers are used to refine features which already exist within your dataset. Tokenizers, principal components analysis, scaling and normalizing your data are all part of feature transformation. Tokenizers are typically used with text data. You might want to split the entire document into paragraphs. You might want to split your paragraphs into individual sentences, sentences into words. Any machine learning library will offer simple functions to help you perform these transformations. One of the most common feature transformers that you might have used before is the one-hot encoding. One-hot encoding is typically used with categorical data. Continuous data tend to be numeric values within a range. Continuous data can be sorted and ordered. Categorical data, on the other hand, comprise of discrete values. These discrete values may not have a specific order. Now, these discrete values need not be numeric, but ML algorithms can only work with numbers, which means that categorical data needs to be converted to a numeric form, just like text. One-hot encoding is one way in which categorical data can be represented in numeric form. Numerical encodings of categorical data should never be ordered. Let's take an example of a categorical variable. Categorical variables have discrete values such as days of the week starting from Sunday and ending on Saturday. These days of the week can be represented in numeric form using one-hot encoding. Let's say you wanted to represent Monday in a feature vector where every element of the vector represented one of the days. You'd have the value 1 in the position for Monday and 0 in all other positions. Similarly, if you wanted to represent Thursday, you'd have the number 1 be at the position corresponding to Thursday. All other numbers would be 0. In one-hot encoding, the position of the number 1 corresponds to the discrete value that this numeric vector represents. Another feature transformation that is common when you work with machine learning is the standardization of data. This is because many ML techniques work best on standardized data, and standardization prevents some particular data series, which is very high variance, from dominating your data set. Some of the ML techniques that require standardized data are principal components analysis, which we use for dimensionality reduction, and lasso and ridge regression. Let's understand what it means to standardize your data. Here is a feature vector which has some numeric values. This has n rows, that means there are n records, and each record is made up of k features. A single column corresponds to all values for a particular feature. Let's say that column represents the height of an individual. That column is the height of all students in a class. Another column might correspond to the weights of all students in a class. The rows are the individual students. In order to standardize this data, you would first find the average across all values in a column and the standard deviation for these values. You would standardize this data by subtracting the average of the column values from every number in the column and dividing that by the standard deviation. As a result of this standardization, each column of the standardized data has a mean of 0 and a variance of 1.